Okay, yeah, and then after that we will get into a bit of Canister development and a few stuff so that we can kind of see in action some of the things that were discussed in the tutorial and kind of do some demonstrations on that. So let me share my screen.
Hello, everyone, and welcome back.
Yeah, I'll see my screen well, I suppose.
Yeah.
Okay.
Back to another episode of the Internet Computer Developer Journey. My name is Jessie, and in today's episode, we're going to take a deeper dive into canisters in episode 0.4, Introduction to Canisters. In the last episode, episode 0.3, Setting Up the Developer Environment, we downloaded some tools that we'll be using to develop our own canisters on the Internet Computer. And in episode 0.2, Internet Computer Terminology, we went through a couple different phrases and terms that are used to describe the different components of a canister, such as the canister's controller or the canister's identifier. Today, we're going to be talking a bit more in depth about what a canister is and why it's so important to our developer workflow on the Internet Computer. Essentially, canisters are at the very core of doing anything on the Internet Computer development-wise. Whenever you're going to create a project on the Internet Computer, it's going to be comprised of different canisters. So it's very vital that we have a fully comprehensive understanding of what a canister is. So that's why today we're going to dedicate some more time to diving deeper into canisters. So we're going to be using this documentation page, 0.4, Introduction to Canisters. And while there's a lot of great information on this documentation page, I've simplified some of the key concepts into a quick PowerPoint. So that we're going to go through that now, just so we can get the core takeaways together. Then, if you want to read a little bit more, you can check out the developer documentation, this 0.4 Introduction to Canisters pages, which I highly recommend that you take a look at as well, in addition to this tutorial video. The link to that documentation will be in the description of this video below. So now let's take a moment to do a fully comprehensive introduction into what a canister is. So a lot of the times you may see the Internet Computer canisters referred to as smart contracts on steroids. And that's a great way to describe them since they are both source code and software state. So on other chains like Ethereum, a smart contract is just a piece of code. It does not have a software state that is coupled with the code. That's what makes canisters unique on the Internet Computer, is that they contain both the source code and the software state. So a software state is a persistent record of changes. Changes can be made by making calls to the source code's functions. So if you make a call to a canister's function and the call changes the state of the canister, typically that will be an update call. That change is going to be recorded in state along with all of the other changes that have been made to the canister state since the canister was created. Another unique feature about canisters is that the source code is always compiled into WebAssembly, or WASM, and then it's associated with a module of stable memory. Stable memory on the Internet Computer is the Internet Computer's long-term storage. So whenever you have values that you need to be stored long-term, such as persisted across canister upgrades, you're going to want to store them in stable memory. And we're going to dive deeper into stable memory and stable variables in a future module. But for now, it's just important to know that source code is always compiled into WASM, and it's always associated with a module of stable memory. It's also important to know that canisters can be written in any language as long as it can be compiled into WASM. And there are several different SDKs and CDKs that can be used to write canister code in different languages and then compiled into WASM. Some of these are Motoko and Rust, which are natively supported by the Internet Computer's IC SDK. Or there are also community contributed CDKs such as the Python CDK and the TypeScript CDK. So to talk a little bit more about Canister architecture, we already covered that there are several different languages that can be used to write the source code for your Canister. As long as it can be compiled into WASM, it can be written for Canister code. So WASM is a low-level instruction format, and it's supported on the IC since it's very portable and it's broadly supported across different platforms. It also abstracts program execution across most modern hardware, making it extremely versatile to run on different nodes across the ecosystem. Another important aspect of Canister architecture is an actor. So an actor is an object that processes messages within an isolated state. Actors also enable messages to be handled remotely and asynchronously, which are two important key components to running code on the internet computer. Since Motoko is developed specifically for running Canister code on the internet computer, Motoko natively is an actor-based programming language. When a Canister is written, a Canister will always include the compiled code for just one actor. A Canister cannot contain code for more than one actor. In addition to that code for that single actor, canisters can also include interface descriptions and front-end assets. So canisters aren't restricted to only containing actor code. They can contain other pieces of code, like I just mentioned, but they can only contain code for one actor. This next slide contains this familiar graphic from episode 0.2, Internet Computer Terminology, and this is just to review the different canister components and terms that we talked about in that episode. So if you remember, the canister identifier is a globally unique identifier for a canister that can be used to interact and make calls to that canister. And a controller of an individual canister is a principal value that can be a person, an organization, another canister. Principals, if you recall, are not specific to one type of entity. They can be used to identify several different types of entities on the internet computer. Canisters also contain a cycles wallet, which holds the canister's cycles that are used to pay for any resources used by the canister. And then in addition to these three components, we have the smart contract code, which we just chatted about, the different languages that smart contract code can be written in and that it will be compiled into WASM. And then the canister state, which refers to the result of any operation, function call, or transaction that changes the information that's stored within that canister. So now we're going to move on to the different types of canisters. We briefly mentioned these in episode 2 with the internet computer terminology as well, but we're just going to dive a little bit deeper into the definitions of these types of canisters. So backend canisters are the part of the application that does not come in direct contact with the users. It hosts the application's primary source code and functionality, and it typically does not contain user interface assets such as HTML or CSS. When a project is created with DFX, the file structure for a default backend canister is created, and I've included a screenshot of what that looks like in the file system below. There will always be a folder that has the name of the project, so in this example, Hello World, and that is always pre-appended to the word backend, so backend will always follow it using an underscore as the separation character. And within that backend canister, there will always be a default main.mo file. And so this will always be a simple Motoko file that contains a default hello world actor definition that uses a simple method to return a hello world message when the method is called. So next we have front-end canisters. So front-end canisters typically contain the part of the application that's used by users to interact with that application's functionalities. And these are the canisters that typically contain different assets used to create that front-end interface like CSS, HTML, JavaScript, or React. Front-end canisters on the internet computer are also commonly referred to as asset canisters since they hold those front-end assets. When a project is created with DFX, the file structure for the default front-end canister is created using the following format that I've included a screenshot to on the bottom. So in this, you can see that it looks similar to the back-end canister, where it has a top-level directory that has the name of the project pre-appended to the word front end with that underscore as the separating character. But the difference here is, instead of just containing one file like the back-end canister, the front-end canister by default has two subdirectories, one called assets and one called source. In assets, there are a couple different visual assets like the favicon, the logo2.svg file, a CSS styling file, and a simple asset text file. And then in the source directory, we have the index.html and the index.js files. So in addition to backend and front-end canisters, there's also kind of a catch-all category that is known as custom canisters. So custom canisters don't fit into the front-end or back-end canister definitions. They might include a mix of both back-end and front-end functionalities, or they might be used for specific functionalities within your application. So for example, if you have a social media application and you have several different components of that social media app, you might have one that handles all of the user's profiles. You might have one that handles all of the messaging within the application, and you might have one that has all of the group activity for the social groups on the platform. You may split these three different core functions of the application into three different canisters so that they can be referenced by other canisters and help with simplifying management of those individual functionalities. So there might be instances where the profile canister needs to interact with the groups canister, or the messaging canister needs to interact with the groups canister, or different cross canister functionalities like that, where it makes sense to split things for the DApp into different canisters in that manner. And that would be an example of a custom canister setup. In addition to that kind of setup, custom canisters also include the Internet Computer System canisters. So these are canisters that help provide core functionalities for different services on the Internet computer. And a couple instances of those are the Internet Identity canisters, the NNS canisters, and the Management canister. So when you start to develop your application, you may be wondering, should I use a single canister or multiple canisters? If you're developing a simple service-based application and it doesn't have a user interface or any front-end assets, then a single canister might be a good choice, since it's going to include simplified management. It's going to have a simplified canister upgrade process. So whenever you want to make changes to that canister, it's going to be a little bit more simple. And you're also only going to have one set of candid interface descriptions. And we're going to talk a bit more about candid in a future episode. However, if your application is intended to have both front-end and back-end assets and logic, then it might be a good setup to have at least two canisters, one to handle the front end and one to handle the back end. This is a pretty standard structure, and this is the default structure that DFX uses whenever it generates a new project. And like I mentioned in the example talking about custom canisters, sometimes it's beneficial to separate different reusable services into their own canisters so they can be imported or called to from other canisters, or even be made available to other developers, such as using the DFX depths functionality, which is a way for canisters to be published and then pulled by other developers into their projects. And we're going to cover DFX depths at length in a future episode, but just make note that that is a possible workflow as well. So canister communication. So we briefly talked about canister communication in episode 0.2, but we're going to dive a little bit deeper into it here. So to recap, canisters communicate with other canisters through the use of asynchronous messages. Each of these messages is executed in isolation because this allows for increased levels of concurrent execution. Messages can also be replies to other messages, or they can just be requests to other canisters and other outgoing external services, such as using HTTPS outcalls. The result of processing a message could be a change to the canister state, a reply message to another canister, or even the creation of another additional canister. If a request requires additional requests to other canisters, such as calling one canister and then that canister in turn needs to make a query call to a third canister, then the first canister may wait for the other canisters to reply first before it returns its response to that message. When talking about canister communication, the term trapping may come up occasionally, and trapping is when a canister fails to reply to a message. So when this happens, the canister state gets rolled back to what it was before that request was made. And remember, canisters can always communicate with external entities like end users or external services. Canisters are not limited to only communicating with other canisters. And another important thing to make sure we have front of mind is that update calls are always used to write changes to the state of the canister, whereas query calls are used to read information from the canister's current state. So earlier in that canister component and terms diagram, we had a canister controller labeled, which was a principal identifier that was labeled as the canister's controller. So let's dive a little bit deeper into what a canister controller is and what it can do. Canisters are managed by controllers. They can have one controller or they can have several controllers. So a canister's controller can be a centralized or decentralized entity. So it can be a single user or a group of users, or a canister's controller can even be another canister. Now, it's also possible that canisters can have no controller at all. And if this is the case, the canister is then an immutable smart contract, since controllers are responsible for deploying and maintaining the canister. So if a canister doesn't have a controller, it can't be updated or maintained. So that makes it an immutable version of a smart contract. Controllers are the only entity that can perform those types of actions with a canister. So controllers are responsible for updating, deploying, starting and stopping the canister. They're also responsible for changing any of the canister's parameters, adding or removing other controllers, or even deleting the canister. One of the most important workflows for canisters, however, is updating canisters, which is something that controllers can do by submitting a new WASM module to replace the existing module. So when the WASM is updated, the canister's WASM memory is cleared, but the canister's stable memory remains. And that's, if you recall, I mentioned that stable memory is the Internet computer's long-term storage and that it persists across upgrades. And that is a very key functionality of stable memory and canister architecture that we're going to cover at length in a later episode. So lastly, we're going to talk a little bit more about cycles and resource charges. So I've mentioned in a couple previous episodes now about cycles and how important they are since they're used for paying for a canister's resources. And ICP tokens can be converted into cycles, and cycles must be deposited into a canister cycles wallet in order to pay for every operation performed by the canister while it's running on the mainnet. If a canister runs out of cycles and it can't pay for further operations, it will be uninstalled and the code and the state will be deleted. To prevent this from happening, a lot of developers will set what is known as a freezing threshold, which is the ability for the canister to stop accepting requests if the cycles balance dips below a certain point. That way they aren't continuing to burn cycles and are at risk of running out of cycles. So that is something that is very important for developers that have applications live in production to be aware of and know how to set up. And that's something we're going to cover in our module dedicated to managing canisters. So how are these resources charged? So memory usage is charged at regular intervals based on the canister's usage. Computational power, however, is charged at the time that the computation is performed, and there is a limit of how many can be performed per round, and that is something that is an intentional design choice for security purposes. Lastly, we have network bandwidth, and so the cycles for use network bandwidth are charged at the time of usage, just like the computational power is. And the cost is calculated based on the size of the message's payload prior to the message being sent. And there are breakdowns of all of these resource charges with some example figures on the gas cost documentation page to give you an idea of how much different simple operations can cost. So that'll wrap things up for this episode. In the next episode, we're going to have an introduction to languages, where we're going to talk about
Okay. Yeah, that was it for this video. Hopefully you learned a few things from there. Before we proceed to the next phase, I don't know if there are some questions at this point. Before we proceed. In the chat. Okay. Okay, that's fine. So we are basically going to create a small canister and deploy it locally, and then kind of in Motoko, and then kind of investigate a few things that are being mentioned here, the issue of cycle and how you can use TFX on your canister and deploying it and everything. So for that. So let me share my screen. Okay. So let me continue with my cool project here. Just open it in VS Code. Okay, so we will be going with Motoko. I'm sure most of you are familiar with programming from what I have seen. So Motoko is a very easy language, really. Just a few concepts. If you're just a programmer, you see that there are just a few concepts that are easy to grasp. But after Motoko, since we have kind of a lengthy time for this bootcamp, we'll get to TypeScript, to those JavaScript developers who will be more comfortable with the JavaScript. We'll also do TypeScript so that you'll be aware of both sides and decide what will be best for you, what you see easy for you, and so forth. Because there's usually a debate, like people would like TypeScript more because they're familiar with JavaScript, and Motoko is a new language. But in actuality, in the actual development of Canister, in some cases, Motoko might actually be the easier one to go with. depending with how you see it. So anyway, we will get into some details on both with you guys, and then by the end of this bootcamp, you'll be equipped with knowledge from both sides, and you decide which one to continue your development in the internet computer with. Another important thing before we proceed is for you guys to, I'm sure you're developers, you might have GitHub already, but if you don't have, try to create a GitHub account if you don't have already. We have some kind of challenges, but they're basically just canisters, unique canisters, which you will have to create for yourself. Like we will teach you some stuff, how to do some stuff, and then you will have to create a unique canister of your own with an implementation of your own, and then that's like a prerequisite for the hackathon. You need to have that canister of your own, your own unique implementation, and yeah, depending how you're understanding, it can be a simple one or it can be quite big and complex, whatever you feel. Okay, so in Motoko, there's just a few things to kind of keep in mind with a new language. They're just familiar terms, like there are declarations, right? Declarations. Okay, settings. My spellings. Declarations. We have expressions. We have expressions. We have a program. We have values. We have variables. So, for example, a declaration would be something like just simply declaring some value. Declaring, like, let's say value x. Let x is equals to 1. That's a simple declaration. And it's a constant. As you can see, we are using let. And then you can, in a variable declaration can also be like in a form like y is equals to, let's say, x plus 1, right? Yeah. And then an expression, as you might imagine, will be kind of combining both of this, like x, what is it, times y, what is the plus, let's say x, something like that. That would be an expression. So, and then like we then have variables. Variables are like declared with the keyword var. If you would like to change that value at some point, like I said, this x, you can't update it. But if for some reason, which is like in most cases, you want to update the values, you go about it with the keyword var variable. Yeah, we'll be doing a bit more of this. You will get the hang of it. And then there's yeah, and of course we'll share some documentation which we can go through actually. right now for you guys, so that when you want to kind of get into the weeds of Motoko, you can see where you get the particular information. Motoko, let's see. No, languages. Motoko based library. So it's on Motoko, and then go to Motoko based library. So this is where, like I say, most of the useful information is, right? With arrays, associated arrays, blobs, Boolean, you name them. So this is where you come if you want to see how the array works in Motoko. You can see we're on array, and like this is the interface exposed by the array. Tabulate, freeze, store, equal, find, sort, all these. So it will be handy if you're dealing with your project, doing some coding, and then you're wondering, how can I do this here? Just come and see what's possible. The functions that are and look at the interface that is exposed by the array. You can go to floats, hash maps. Yeah, you can see with hash maps, which in Motoko at this moment, the ones you most likely want to use if you are like storing big things, are not hash map exactly. Hash map and try map. So we have hash map and try map. They expose almost to the same interface. The only difference is like this try map, it uses, what is it? It uses a try. Yeah, the try map class, it uses a try data structure. Like under the hood, right? And then hash map, it uses, what is it, an associated list. So it's something you can poke around with. We're going to get into the code soon and see what some of that will be working. So anyway, yeah, I mainly just wanted to show you where you can get the documentation. Come to languages, Motoko, and then you scroll down to Motoko based library. There's also a Motoko book. Motoko programming language book, which does some good explanations. I think this is it, yeah. I think let me also just share with you guys. This one is good. You can download it as well. So let me share with you guys. You also send the Motoko book, and then yeah, the best library, you can just find it on the website. So as you can imagine, you definitely need to use some library in your code. One of the most common is like how to print something, how to debug your code. Python, we have print, JavaScript, console, log. Here in Motoko, we have debug. So there's this library called the debug. So if you have installed the Motoko language support extension, you should be getting these suggestions. So I just typed it here and then I go to debug here. I can import it. So this is how you import the library. So you can see Motoko base library and then debug. This is how you import like most of the libraries. You might want an array, a hash map, a try map. This is basically how you'll be doing it. And then yeah, this suggestion is okay. This is how I might like print debug hello in my code and like try to investigate whatever is happening here. So let me try to deploy this and test this debug. Okay, again, when you try to run your project, you might get this error. It just means, what is it? Error happened during communication with the replica. It just means you haven't started your lockout yet. Okay, go ahead, Ben, you want to say something?
No, that's fine.
Okay, cool. So you just need to start the local replica with EFX start clean background. So you can start it in the background or you can have it run live with you here. But usually in the background is kind of better because you can close terminal by accident and your canisters won't stop. Like your local canisters you are playing with won't stop, right? But if you run it without the background like this, if I accidentally close this terminal, yeah, it will stop. And whichever canister I was working with or developing and testing, it will stop. So it's usually best to do it with just TFX start clean background so that it runs in the background. So and then if you just want to stop it, you can stop with TFX stop, and then it will stop. Then you let it just start it in the background and let me deploy now. TFX deploy. So if you do TFX deploy, it will deploy everything that has been defined in the TFX choice of JSON. But if, let's say, you don't want to deploy everything, like, deploying, let's say you have a lot of canisters in here, you have like 5 canisters here. Doing TFX deploy and having them all deployed every time, it will take a lot of time. So in those cases, what you might want is just to deploy a single canister. Let's say I just changed some code in here, and then I want to test it. I won't have to deploy everything in here. I just want to deploy this canister only. So I can specify the name of the canister. So this is the case not only in Motoko, but across all whichever language you are using to develop. This is a GFX thing, not a Motoko specific aspect. So you do GFX deploy, then you specify the name of the canister. So Michael, this one is too long. Let me rename this to just backend. Okay. Yeah. TFX deploy backend. So it's deploying. So previously we didn't get to show you the candid interface. It was highlighted in the video we had watched, but we get to see it now. This is the candid interface. It is automatically generated by the CDK. When you deploy your Canister, the Canister interface will be automatically generated, so you can play around with this. If your Canister it's a live Canister, if you deploy it on the Internet Community Network, you can actually log in with your internet identity, and then you can start doing some authenticated calls. So I deployed here to test this debug function. So let me say quit here. Let's see. No. Yeah, you see here. Hello me. That's what the debug is doing here. So important if you are developing your backend canisters with Motoko, this is how you do it. Yeah, and then okay, let's go back to the code. Yeah, and then you might have some of your own modules you want to use in this. As I said yesterday, like your project will definitely start growing bigger. You need to have good code organization, having some code in these files. So let's say you have a file dedicated for types. The subtypes you are having. So it will be a module. Right. So you see, in a module, you can actually put some functionalities in there, some types, some actual functions that are running in there, some utility functions, you name it, as long as it's not dependent on the state of the canister. So anyway, we'll get to that. For now, it might not make sense, but we will get to that. So here, I'm just want to declare some types. Let's say I'm creating a user. So I'm going to have my type in here. So since it's a separate module, the type will have to be public for it to be accessed in another file. I think this is a common thing. So public type user. Yeah, let's go with that. That will be for email and no password. We don't need the password. Created. Yeah. No. So on strings, we don't have strings. In Motoko, we have text. We have text. Yeah. We have text. So this is how you would go about it if you are like almost every application. Yes, will need to have some users, right? And you definitely need to store users. So in what, let's say in MySQL or say in Django, you create a schema, right? A model. You declare the values you'll be having and the fields you'll be having, whatever the table is, right? Here in Motoko, yeah, and even if you're using Rust and TypeScript as well, the schema, you definitely declare it as a type like this, giving the different data types you will be having. So created at, this will be time, right? So you can use the time library, time dot time, right? So in Motoko, this time it will be measured in nano milliseconds, right? So it will be in those nano milliseconds. So just something to bear in mind. So if you go to the time library, right, you will see that the actual time here is just an int. So it's just kind of a tip, like when you are having some time somewhere you want to store, you might not have to trouble yourself with importing the time library. It might be good for code readability to understand, like here we're having the the time, but you can just use like an int, and it will still be good because it's still basically the same thing. Unless you want to code to store the date in some other way, like let's say a string, whatever. So time, okay, int, that's fine. So now, how will you use it in your application? You can just import it. So import types here, so it's picking it up, suggesting. So I can click this, and then it will import. So you give it a name. You don't need to export it, let's say, as what's happened in some other languages. Once you're like this, once you point the path, the right path to it, you can give it any name you want here, and then you just give the path to it. So if it's in the same directory, you can just do it like this or this, and it will still work, right? Yeah, so that's how you will import modules. And then we want to use the user type. So we can just say okay. As I want the function to create a user. I'm looking at our time and getting worried. I want to get into a lot of details, but anyway, let me just cover a few things I wanted to cover. So let's say we just want to create a user, right? We'll create a function, a public function, add user. So yeah, we can have the argument of types dot user. Yeah, and then so this is how you declare the functions. And then here the asynchronous function, especially if you are calling it this function, if it's a public app function, it have to be an asynchronous function. So here you pass in the parameters, the input, and then here you pass in the return type. So you define it as async. And then what do we want to be returned after adding a user? We can return nothing and then just put this, or we can return nothing. we can return nothing, and then okay, whatever it's saying here. We can return nothing, or we can return something, whatever we want to return. Let's say the user type. So it will be types.user. And then whatever we have here, we are not adding this user to anything. We can just say return X. So you can see this is kind of a really useless function. We are just passing it, and then it's returning what we are giving it. So as you can see here, we are repeating types. So what you might want to do to avoid this repetition is to say, so type user types.user, and then now you can simply access the user type like this. And yeah, there you have your function. So we will get into the details. There's a lot, as you can imagine, like how exactly do we actually store the users? How do we remove them? Because of our time, we are now kind of limited. But there's just a few things I would like in the next like 3 minutes or so. So as you were listening in the video we just watched, was the issue of like canisters having controllers, canisters having cycles, controllers topping up cycles, and whatever that was being said there. So once you deploy, okay, so once you have your CDK set up on your local environment, right? You have your identity, your command line identity set up. That will happen like it will happen by default once you have it. Once you have it installed, when you try to run anything, you will have a command line identity created for you. So you can see the identities you have by doing tfx identity list. So yeah, I have a lot of identities. I've been busy. So yeah, you have these identities. You will see the identities you have. The default one is the one that will come by default, and then these other ones are the other one that you will create for whatever purposes you will be having, and you can also easily remove them. You can also easily transfer them as well to another, from one PC to another. You will, for whatever reasons. So anyway, in the video we had that like each canister has a controller, right? So the initial controller of the canister is the one who deployed it. So you can see the information about your canister by doing this command dfx status, and then you give the name dfx canister status backend. So this is my backend canister. So you can see this is the information. So this information, like this detailed information, is available to the controller only. So you can see that the freezing threshold, the one that was being explained, so you can actually modify this freezing threshold so that like when your canisters exceed such level, your canister will stop accepting messages to save itself from crashing. Then here you can see your cycles balance. So by default, canisters, when you deploy a canister by default, it's deployed with around 3 TC, 3 trillion cycles. Yeah, you see all this information, number of queries, what. And you can add controller. You want someone, let's say you want someone to be able to update the code of this canister. Controllers are the ones who can only update the code. So let's say you want someone to be able to update the code. You can edit them as a controller. We will look into that in upcoming videos. You can also remove the controllers. Yeah, our time is gone, but I think I would just urge you guys to try to have the developer tools installed so that tomorrow we can start some development, some playing around with code, and see you spinning up your canisters, calling it, and we'll get to things like the front end and everything in the coming days. So before we close this session, are there any questions? Our time is already up.
None from me. Thank you very much.
Okay, that's cool. So, okay, I've killed it. You're all right. Okay, great. Thank you guys for joining in. We meet tomorrow. This video will be available. Matthews, how is it?
Thank you. See you
All right.
tomorrow.
See you tomorrow. Okay. Good night, guys.